So the last section in this chapter talks about how you graph inequalities, and I want to just recall with you about a few things that are important from this chapter. When you graph something, it doesn't matter what it is. If you're graphing a line, for instance, let's say that that's the line 2x plus 1, and we're graphing an equation in two variables. It's important to know what exactly it is that you're doing. And the first thing that I suggest that you do, and this is not the only thing that you do, is you create a table of values. For example, if you plug in 0, the answer that you get back for y is 2 times 0 plus 1, or just 1. So if you plug this in and you get 1 back, the answer that you get is 0.1. And there's two ways to interpret this. The first one is that this is a point on the line. And this is the main reason that we graph things. We graph things to find points on a line. But the second thing that this can be interpreted as is that this is a solution to the equation. Okay, that's the more important thing. This is a solution to this equation that we created. Now, when we talk about solutions, we can do the exact same thing with inequalities as well. When we find solutions, we're trying to find numbers that work. But what we're going to find is that when we graph lines in this case, in this section, the lines that we produce are not going to be the only things that work. And I'll show you what I mean for this. But when we find a solution for this, it's not going to be just a line. It's not just a line. It isn't just a line in this case. Okay, it has to be more than a line. It's actually going to be what's called a solution region, or area. So the area that we produce is going to produce a lot more than just points on a line for answers that work. But the idea is that you want to create something that is like a line first. So I want to try and make this a line, and then after that we deal with it like we would any other inequality. So how do I deal with this? Well, we have this inequality. I'm going to try and solve for y. So I'm going to subtract 3x to the other side. And I get negative 4y is less than negative 3x plus 12. Divide by a negative 4. And I get y. And I'm going to leave this sign alone for a second. These two negatives, when you divide them, become a positive 3/4 x minus 3. Now I left this alone for a reason, because when you divide by a negative, an inequality becomes reversed. So it looks like this. Now this is no longer saying that y is equal to this. So we're not talking about graphing a line like we did up here. So how do we graph something like this? Well, this right here is a boundary. So what does that mean? That means that this line, if it was a line, creates a boundary between solutions. Okay? So we're saying that this has got to be, all the solutions are greater than this line. So I'm going to treat this like it were a line, but I'm going to do something just a little bit different. So I'm going to go to 3, put a dot there, go up 3 to the right 4, and I'm going to draw a dotted line. Okay, I'm going to draw a dotted line. Now, these points on this dotted line are not solutions to the inequality. They're not solutions to this inequality. So we have a problem. We just graphed something and none of the points on this dotted line work. So how do we find points that do work? Well, we're comparing things to this line and we're saying that everything above this line is going to work. So all we have to do is shade above this line. And everything we pick above this line will work. For example, if I pick the point 0, 10 and I plug this in, I get 3 times 0 minus 4 times 10. I get negative 40, which is less than 12. That is a true statement, so that point is a solution, so it is part of the solution set or solution region. So the shaded region is the solution region. Now I'm going to do the exact same thing with this one. I'm going to solve this. I'm going to treat this like I'm trying to solve a y. So I'm going to subtract x. And I get 2y is less than or equal to negative x plus 4. Divide by 2. And I get y is less than or equal to negative 1/2 x, because that's a negative 1 here. I could say it's negative 1/2 x plus 2. So I have this solved for y, or y is completely by itself. But now this is different because we have an equal sign here. So we can include the line as well. So the line is part of the solution. So the line's part of the solution set. So I have to graph this line. So I'm going to go to positive 2. I'm going to go down 1 to the right 2. I'm going to graph a solid line now because the line is part of this solution. So that means points on the line work. So points on the line work. So points on the line work. Okay? But points on the line are not the only points that work. We're also looking for points, because it's less than, we're looking for points below the line as well. The less than means below the line. Okay? So I'm going to shade below the line as well. So I could pick any point on the line as well as below the line, and it would work. If I picked this point here, which was 0, 2, if I picked the point 0, 2, that would work. Right? Now, it doesn't matter which ones I pick, but those are all solutions for this problem. Everything that's shaded, and including the dotted line or the solid line. Now we're going to run into a problem that we have different here because there's only one variable. So how do you graph something that only has one variable in it? Well, if it was just y equals 2, that means anytime I drew a table up, any x that I picked, it didn't matter, y was also or always 2. It didn't matter what I picked for x. Y would also always be 2. So this is a horizontal line. Okay, so it's a horizontal line. And this is where it hits the axis at 2. So I'm going to draw a dotted line through 2. And it's dotted because of this. We can't include the line. So the line is not part of the solution. So the line is not part of the solution. Now, when I say y is less than, when we think of less than, we think of things below it. So I'm going to shade everything below it. So I'm going to shade everything below it, and there is my solution region. Finally, if you have something that looks like this, we have a variable for x. Now it doesn't matter what value of x I pick, or excuse me, y I pick. I can pick y as 1, 2, 3, it doesn't matter. X will always be -1. Okay, it doesn't matter how I pick any value for x, or for y, excuse me. Any value of y I pick, x will always be 1. So this is a vertical line. And it goes through the x-axis at -1. So this is a vertical line. I'm going to have a solid line Now, we can't shade above or below this time, so you have to think in terms of a number line sense. If you're greater than, in terms of x values, you shade to the right. Now, I'll show you how a point works here. If I pick this point right here, that's 10, 1. And is that a solution to this? Well, if I pick the point 10, 1, 10 is the only point that I can plug in, and 10 is greater than or equal to -1. So this is a solution for this graph. So this is my solution region.